the actual main part of our presentation, our housekeeping rules. For those of you that are not familiar with the general housekeeping rules of these webinars, all attendees are muted for the duration of the webinar. If you should experience any technical issues, use the questions window to communicate with us. We do have some information, some handouts that are available in the control panel there. Got an arrow pointing to them. You can just drag and drop them or view them directly. Feel free to post questions anytime during the webinar using the questions panel, but we will be waiting to the actually end of the main presentation to address your questions. If we don't get them all answered, we'll be sure and get back to you with email. For those of you who are not familiar with Larson Software Technology, we're based in Houston, Texas. We were founded in 1984 as graphics technology and technology experts for over 30 years. We develop powerful, innovative graphics software for both end user products and toolkits based on open standards. We've promoted since our beginning, the use of CGM with a free CGM viewer, which we've now replaced with an online subscription version that you can get on our store. We're the developer of the first HTML CGM viewer to eliminate the need for plugins to view CGMs in browsers without a plugin. We're a member of the CGM Open Foundation, and our products simplify the technical graphics workflow for technical publishing professionals. So with that introduction said, now let me turn you over to David Manick for the main part of our presentation.
Thank you, Don. Good afternoon, good evening, good morning, depending on when you are. So this is David Manick. Yeah, I'm excited today to show you some developments we've been doing around the 3D area. So we have some topics to go through, and more importantly, we want to try and show you a live demo of some things we've been working on. So we'll start off with kind of an introduction. We'll talk a bit about 3D illustrations and the process of producing them, information sources, data exchange, actually authoring that 3D data, and that's where we'll look at that in more detail in a live demo. And then following that, we'll talk about how do we, once we created that information, that 3D data, that content, how do we then display it? So you're going to need some kind of viewer to do that. If anybody's familiar with 3D and the 3D space, you'll find there's a lot of viewers out there, usually standalone. There are some online ones, but what we've discovered is there's nothing really that's aimed specifically at the technical publications market, or certainly not anything that's open. So we wanted to try and do something based on open formats and open technology, so you'd find it easy to integrate into perhaps your solution if you have an IETM or something of that nature. So then we'll do it like a live demo of the 3D viewer as well. And then summary, and then any questions, please, as Don's mentioned already, if you want to ask any questions, put them in the panel. We'll be pleased to try and answer those at the end if we can. If not, we'll get back to you on email. So, brief introduction. I think everybody is familiar with the illustrations on the call today, on the webinar, and you know, the traditional way of creating illustrations has been 2D, and we have a lot of legacy 2D out there that's still being used. But if anybody's aware of illustrations, one of the things, key things, was trying to make a 2D illustration look like a 3D with certain line techniques and so forth. But today we have more of an opportunity to deliver actually 3D illustrations. Obviously electronically, it's not something you can deliver on paper. So 2D is still relevant, I think, in that realm. If you've still got to deliver a PDF, or you've still got to deliver a manual that's printed perhaps even, then 2D is still relevant. So with opportunity, we also have faced challenges. So how do we source the 3D data? That would usually be from a CAD system. How do we author it? How do we kind of repurpose it into some usable form for technical information? where do we use those in the manual? What's the value of adding a 3D as opposed to a 2D? And how do we deliver that via a web browser? Certainly that would be the environment that most people nowadays would choose. So we'll discuss that in this webinar. We'll show you what our approach is and how we've trying to solve those issues. So I mentioned the sources of data. I would say predominantly 3D CAD systems are obviously going to be the source of data. I know that some illustrators are probably trying to recreate things in 3D as well themselves in different systems, but certainly for engineering, from an engineering point of view, then the kind of truth or the truthful information or the verified information for 3D is going to come from the CAD system or the engineering system itself. And certainly there'll be some data exchange involved. How do we get it from one format into another, a format that perhaps we want to deliver to the web? So that is also something you have to bear in mind. So we have the possibility of probably using two different formats, open and native. So open formats, obviously not owned, non-proprietary, and they do exist in the CAD world as any other world. So we have IGES and STEP, which we'll talk about in a second. But there's also native formats, which are usually owned and proprietary. So if you're going to move those over to another system, then that system has to support that native format. So that'd be a bit more kind of difficult to do because the owner of the format would have to have published it in some way. So open, I think, is always the best choice, and it will give you still good, reliable data. So the 3D Exchange formats we're looking at really, from our point of view, is the open ones, which you could look at IGES, or you could look at more predominantly today is STEP. So STEP, it contains all that engineering information that we really need to kind of repurpose it. The only downside of this is the size of these files, but certainly most computers nowadays can handle these file sizes, and the software that certainly we'll show today is able to process the large file sizes with the correct hardware. So STEP and IGES, predominantly we our choices for the data exchange with the CAD system. Native formats, you've probably all heard of things like SolidWorks and CATIA and Creo. So it would really be a dependency there on supporting those native formats, which we've looked into and we're considering. But at the moment, really STEP and IGES really satisfy most of the customers that we're talking to anyway. Just to add to all the 3D formats out there, which there are many, we created our own. You probably asked the question why we did this. The reason is that we needed a format that we could save into. So once the data exchange has taken place, like how do we then save something and then reopen it at a later date to work on again at that state? And like things like IGES and STEP just don't work in that way for our system. Well, one is they're going to retain the file size, which we didn't want because of then handling the file becomes more difficult. So what we did is created our own file, native file called VisX3D, which enables us to do everything we need to do within the program, optimizes the data, so it's a lot easier to work with, it opens quicker, and it's easier to work with. So that was the reason we did it, mainly so people could archive it, reopen it, and work on it again. So we're not really positioning it as something you would then use downstream to publish on the web or anything. We have another track for that. So how do we author the data once we've got it through? So we wanted to make that really, really easy. And why do we need to do it? Because of the fact that we feel that the CAD systems are really good at what they do in an engineering environment, but we wanted something that was more specific for technical illustrations. So manipulating the model really easily, adding interactivity, annotations, and also the ability to then go into an IETM. So we tried to give the illustrator, the operator, some good data exchange options, really easy ways of manipulating the model once he gets it in, and also isolate assemblies, explode assemblies, add interactivity and annotations. So we're trying to make that as easy for the illustrator as possible. So this is the first live demo today. I'm just going to switch over so you can see the interface. So if anybody is familiar with VisX Edit, VisX Edit really is our 2D illustration system where you would create CGMs and so forth, hotspot. So this is kind of an extension to that, although it is its own standalone program. So VisX Edit 3D, you could just run this without, you could run any other 2D program with it, not necessarily ours, and still output to things like CGM and then reuse them. So it's a standalone piece of software in itself. So at this point, what I've done is I've actually imported already this, in this case, a step file. It takes about 15-20 seconds to open this. And then once we save it as VisX Edit 3D, it will be a lot less than that to reopen it again. So just to begin with, I'll talk a bit about import and what the menu we have up here. So import means I can import these 3D formats. So we have things like, obviously, IGES and STEP, which we've mentioned already. We're also supporting VRML, which you could even call an old legacy 3D format for in the technical illustration realm. So we've allowed you to bring in old VRML files. gltf is our format we'll talk about a bit more when we talk about publishing. So this allows us to do some round tripping on this particular format as well. So I think you'll find that interesting. And the other one we have here is open. So we could open a VisX Edit 3D file, and this is our native format, or we can save as it. So VisX 3D means we can, as I said earlier, is actually save it in the state that it's in, rather than having to reopen it and then do all the manipulations again. So sounds straightforward, and but it's something we had to work hard on to get that kind of functionality within our own native format. Okay, just to talk about the interface a bit. So on the left here, we have the model tree. So this would be something coming through from the CAD file itself. So the actual structure of the file. So we can see the different parts on here. This doesn't have a great deal of sub-assemblies and assemblies. So you might see, depending on what file you actually bring in, will have different structure to it. But this one's just one of our kind of standard non-proprietary files that we use for demonstration purposes. Yours probably look a lot more different to this. But if I click on, say, something obvious that's at the top here, which is the fan, you'll see that it highlights it. So now we've got this particular part highlighted, and the properties for this part appear on this side here. So if I right click, I can hide the part. So what that would mean, if I did any processes to it now, like we could snapshot it, then that obviously wouldn't be there. So we can easily begin to show and hide parts, and we'll go into more depth as we go along. One of the things that people asked us about when we first launched the software is, can I change this name once it's come through? So we created this properties box. So if you want to actually change the name to something more meaningful, or a part number or something like that, then you can do it up here. And I'll just hit enter, and it will change it in the model tree down here. So it could be a part number, or you might want to add more information to it. So we could easily do that in the properties menu. And this then reflects, you'll see downstream as well. So if we're then publishing this information, then this is going to reflect, say on the web, if we have a parts list as well, that would actually be updated to that as well. So you can really have control over what you show in your end user. So we'll talk about more of the model tree as we go along. You'll see that it becomes active and inactive as we do different things with the model. So you can see as I move over that the parts are kind of highlighted. They're not selected, they're just highlighting different parts on the thing. If I actually select something, you'll see that the model tree updates with that particular part. So there's a two-way interaction between the model and the model tree. If I then click and drag, then I can orbit around this as well. So I can zoom in and out, and I can just move around and get to see the parts I want to see on here. So very straightforward, just to kind of begin to work with the model on the screen. I can also pan as well to fit it into screen and so forth. So I'm just going to change the tab up here at the top. And now I've got some more tools I can work with to work with this model more effectively. So one of the things we obviously realized is that people might want to have preset views. So we can always go back to that initial view, or I can actually set an initial view if it's not the one that comes through automatically. But most illustrations are still done isometric. So we wanted to give the option to actually go through isometric projections quickly. So we just built those in. So you can just rotate around and go to every isometric projection that there is. So this is probably more relevant to 2D files, but also we want to try and make that the same thing in 3D as well, because we still think that's a good projection for somebody to see all the different parts, and is more kind of standard to specifications and so forth. Okay, so zooming in is just with the mouse wheel, or we can use the right click and we can fit this to the screen, zoom to fit a particular part or fit all in the screen. So you'll notice that the right click does quite a lot for me as we go along. At the moment, we're looking at this as a shaded view, but I can also do wireframe. So if I want a wireframe of this, I just click on that. Obviously, it's not really very easy to see what I'm looking at now, but all the parts are still active, and now we've got a wireframe. So you might want to look inside this, how it's constructed, what's behind there, what's inside. So that's how sometimes wireframe is used. If I go back to shaded, I then could select a particular part and just wireframe that particular part as well. So then I might be able to use that as some kind of effect, or just to see what's behind there. So let's just go back to shaded. So you'll notice as well that the speed of this happening as well is really quick. So we've really optimized this for rendering it as much as we can. So it just makes this as easy as possible to work with. Probably not relevant to this demo, but I just wanted to show you we've got a HLR, or hidden line removal. So this is what if we now wanted to output this as a CGM, we can do with this particular function. So I could export this as a CGM file, and it will give me a hidden line removal. So then I've got something I could take into, say, VisXedit or another piece of software that supports CGM, and annotate it and so forth. And I've got a 2D flat illustration really quickly from the CAD data. So this is just kind of a preview mode of what is going to come out. It's not absolutely perfect, but it will show everything will be perfect when it's actually outputted to the CGM. So then you could comply with S1000D and so forth. So I think that's a really cool feature of VisXedit 3D. It's not only 3D, but it has that ability to save as 2D as well. So let me just go back to the shaded view. And I'm just going to go back to the. In fact, we'll keep it as it is, I think. So what I'm going to do now is just show you a bit more how we use the model tree. So we probably don't want to work with the whole of this particular engine, just part of it. So over here we have the turbo. So I don't know if you can see that we've only selected one component of this subassembly, which is the turbo. So if I click on it, I then can select all of it. So I know I've got the whole assembly now. So if I right click, I then can isolate this, and I can just work with this particular subassembly. So I could have done the same thing. I could take a 2D view of that, or I can work with it now as a 3D view. I can still use the same manipulations, say in this case isometric, to bring this to a different viewpoint. So I can still do all that. And we can do some other things as well, actually, to the model. So one of them, if the color doesn't look right when it comes through, then I can get perhaps a more realistic color by modifying the color. So let's just select that and modify and color. And then I can choose a color that's closer to we can do a custom as well, to what actually the component looks like. This is if the CAD system doesn't have it already on there. And then if I just clear that selection, you'll see we've gone to this kind of gray color. So we can do that to all the parts, and that will obviously save, again, when we save that part. The other thing we can do, which I think is a really nice illustration thing, is we can click on the part and we can modify the transparency. So one of the things with illustration is that sometimes you want to show inside of the cover or whatever to see what's behind it. So it just kind of goes over to my other window. So let me just pull this over. I've got two screens. So now I can just use the slider to move over and have the transparency. It might be difficult to see on your screen, but once I remove it, then let's just say done. And just clear that selection. And you can see now that you can see the impeller through there. So we have the impeller in full, and then we see the shaded view of it behind. Now you can actually, again, just going to 2D, we could save this as a PNG file perhaps, or we could save this as a 3D file. But I'm just going, for speed, I'm just going to export this as a PNG, and we'll just take that out. So you could use this in the manual as well. So it should open in probably Paint, I think, in this case. Now it become more obvious that it's just going to, there we go. And there you can see, hopefully, I'll zoom in a bit. Oh, it's gone into VisX Edit, so it's interesting. So you can see there that we got the impeller shaded, and then we got this transparency. And the really nice thing, that will work in 3D as well. So I just wanted to quickly show you that. Okay, so I'm just going to take that. You can still take this transparency off. So I'm just going to quickly do that. Okay, so I'm now going to just reorientate it as well. So I'm going back up to my tools, and I'm just going to reorientate this into another view. I'm going to go, in fact, we're going to go right round, I think, to here. Okay. So now I've isolated. One of the common things that illustrators would do as well, especially for illustrated parts, is they would explode this. So I'm just going to make this a bit smaller. And now I have an explosion tool, and I can do an automatic explosion, which just kind of throws everything everywhere, which might be a good starting point. Or I can select an individual part. So in this case here, let's just say the flange, and manual, and I just move over and then drag that part away. And I can do that with all these parts on here. So it doesn't take long just to move these parts away. We can bring the impeller out here and also move this away at the back. So you can see how quickly it would be to move this away. So we've now got a 3D view of this. So you could have a 3D parts illustration perhaps. Or again, I could go to CGM and 2D as well. So one of the thoughts was, how, if we're going to take this into 3D, how do we annotate this up? You know, what's the best way to do it? So if we right click, I can add an annotation. So add, and then click and drag. So now we're given a box where we could enter various information. So we could perhaps give it a title. You don't have to fill these boxes in, by the way. So let's just call it turbo. We'll call this flange. And we'll give this a number. It could also be a letter as well, depending on your standards. And we can also change the background color. This will become more apparent when we take it through into the 3D viewer. But at this point, we're just really setting that color. So we've got a blue, but I could change that to any color I wanted to. Let's say OK. So here's our annotation for this particular part. So we have number 1, turbo and flange. So don't be too concerned about how this looks, because once we get through into the 3D viewer side, you can really change the style of this, or the style will change. So it can be much more graphical in the way you want to lay it out and so forth. But the color is probably the thing that will be retained. But the actual look and feel of it will change as we'll look at the 3D viewer later on. And obviously I could choose another part on here. Again, add an annotation to this. And this we'll call this a warning and a caution. And we might want to make the text, we'll make that black. And we'll make the background, we'll make it yellow. So. And we'll make that number 2. I'll make that OK. So you could actually kind of follow the color scheme. Say you were working with S1000D, you could follow the suggested colors for that, or create your own if you're not restricted in any way. Okay, so hopefully that gives you a good overview of, say, the authoring environment and how easy it is to actually work with these models. And obviously I could save this now in this state and then go back to it at a later time. And you'll notice that on the left-hand side, the model tree is updated to reflect what we're seeing and what we're now hiding. So even though we're working with we've got the whole model here at our disposal, we can just work with one particular part of it. So let's go back to our slides. So now we have our 3D information. How do we publish that? And this is the real key. So you could take that file into other software that you could perhaps support these things. But what we've discovered is that nothing really out there is really thinking of illustration. Everything tends to be very CAD orientated. So we've got some great CAD viewers out there. There's just so many of them. So what we try to do is create something more that's suitable for illustration. So one of the things is file format. So you want something that's easy to implement in a web browser. You don't want a really big file size. You want something smaller without sacrificing that quality. You want to be able to add that metadata and hotspots. You want interactivity between the text and the graphic. You want the ability to link hotspots to external text or other illustrations. And it may seem a small thing, but a lot of viewers will actually just rotate the text in 3D form. So if you rotate the model, any text on there will kind of reverse out. So you'll see the back of it, or it'll distort it. So actually what we call placarding or billboarding the text, so it always facing you, is really important, especially in technical illustration. So what formats have we got to choose from? There's quite a few. We wanted to stay open again and not obviously use our own native format. And certainly X3D looked promising. It's based on XML. It was obviously a lot of the standards that we work with, certainly with aerospace, defense, automotive and so forth, is based around standards and usually XML. So that looked like very promising. And then when we went into it more, we discovered that there's a lot of overhead on file size and so forth for X3D, which is XML based. VRML was kind of the precursor to X3D. So again, we felt that we wanted something a bit more modern. So we then looked at gltf, and we felt that this would be or look very promising, and it could be something we could work with. So this would be a similar scenario that some of you yourselves in the industry would look at. You know, how do we choose the right format? And it's the same for us as a software developer. We also looked at 3D PDF. Again, it looks like a good format, but it didn't really lend itself too much to what we were trying to do with it, as far as kind of embed it into IETMs and so forth. It seemed a bit more of a standalone format to us, and also very large file sizes. So we came and we really selected gltf. That was our primary. We came to that conclusion after some time and experience of working with it. So gltf, it's really GL is transmission format. So they're trying to give it the same a strapline really as JPEG for 3D. So something really common as a 3D format to move files around. We found it really easy to use, like Google are using it and so forth for 3D information. Microsoft are using it as well and support it in their software. Even PowerPoint supports the import of gltf. So I don't know if I can just go out of slides a second. I don't know where this will, sorry, escape me too. So just bear with me. I just wanted to quickly show that with this here, even in gltf is supported within PowerPoint. So it's a common format. It's a really lightweight format, and it really works well with the web. So that's really one of the reasons we chose it. So sorry for that kind of aside. So, but how do we view gltf? So obviously we can view it in a lot of the Microsoft products, but they've not kind of extended it too far. So gltf is capable of a lot more than they've implemented, if that makes sense. So it can support annotations, it can support interactivity with text. So there was nothing really off the shelf that really did it to our kind of requirements. So this is where we came to the conclusion we might have to create our own 3D viewing technology. So we've been working on this for some time. We're still working on it. And at this point, we're going to demonstrate something to you today, but we are looking and talking to people in the industry as well who can perhaps work with us on this to implement into their technology. So it certainly supports interactivity. It supports annotations that we've just seen. And as we'll see in a second, it also supports that placarding of text. We think that the 3D viewer will probably, well, we're almost certain it's going to be a software development kit. So something you would work with to implement with your technology. We haven't really thought of it as a standalone viewer. It could be, but at the moment we're really focusing on an SDK. So how do we arrive at the viewer we've got so far is that one of our main things we work with is S1000D, and there's a lot of guidelines within the spec, and we say guidelines for authoring the content in a way that is useful for technical manuals. And we try to implement some of those things as best we can, really. The interesting thing is that there's a lot of guidelines in the S1000D specification for the content, but there's no file format. So we felt it important to choose a file format that was open, as the spec is open. And obviously, we didn't go with an XML format. We went with gltf, and that's mainly because it's usability and capability. So if you're interested in the 3D part of S1000D, the chapter 3.9.2.5, it's really is a guideline. It doesn't really give you any technical information. It just gives you kind of what you should be trying to achieve. So the guide really tells you a few things. I've really took these down into a few bullet points. So obviously you want to have a fast display to make it usable. For IETMs nowadays, it really needs to be compatible with HTML5. It needs to support interactivity both internally and externally, support display of annotations, and that last one is the ability to display placarded text. So let's have a look what we have so far. So this is our viewer. We're in Chrome at the moment. You'll see that we have a model tree on the left. Now, when we export from VisX Edit 3D, we automatically export with it a model tree and the model itself. So this is kind of already done for us when we bring it through. And when I actually edited the model tree, I changed that name of the fan. That would flow down here downstream. So we're looking for to show in demo next time a much better workflow of the whole thing coming through. But this is I just wanted to show you this today to show you where we're up to. And at the moment, we're working on a lot of documentation around the SDK, the API, and so forth. So enable developers to work with it in the initial stages. So we'll have an evaluation of this hopefully fairly soon. So we can work with the model as we did before. So I don't know if you see these annotations that they don't go with the model, they stay flat. And they also kind of disappear or fade out when they're behind there, but they are still there. And I can zoom in the same. So I can zoom in. The annotations don't get bigger, they just remain the same size. We will have control over this as well, but we won't be able to. The authoring environment is VisX Edit 3D, so this will be coming, the text would come through in the colors, but we will probably be able to affect the size of this to make it bigger or however we want it, more control of how it looks. So if you notice that I click on a part on here and it highlights on the left-hand side. So the punch or the base is on this side, and the same applies on this side, but it also will navigate and highlight it. So the main rod is now highlighted, and let's try the second. Let's just go over here, side. So again, highlights it in yellow and positions it in the center. You'll also see that the annotations are here as well. So if I click on, say, the base and the annotation, that will rotate round and we'll see that in the center as well. So let's see where else we have it. So this tree can be folded out. Sorry, I just can't see that. So that's the other annotation we have. So it just flips round and shows it. So it's really nice, the interactivity we have. And we still have some of the same things that we have in the model tree in VisX Edit 3D. So we can like hide parts or bring them back quite easily as well. And we can clear the selection. The other thing we're working on at the moment, doesn't quite work at the moment, is like having an isometric view in here. So we're looking for more controls of the model that you might want to see as an illustrator. So you might want to go to a particular view and set that straight away. So although the view sets, it's not quite right at the moment. So these are all things that we're working on. And so you'll see that this is going to, there's more things coming for this. But at the moment, the speed is excellent. The ability to export the tree is really easy from VisX Edit 3D. And you should be able to embed this because it's all based on open technologies. web technologies that you could easily implement into your IETM. Okay, so let's just go back to the slides. So I'm not going to go into any technical things. I'm not the right person to do that today with the viewer, but I think we'll do some more. We'll either work with people directly, or we'll do another webinar just talking about a bit more about the technicalities of the viewer in the future, and what components we've used to actually and how it's going to work for licensing and so forth. So some of the benefits for 3D. I think now it's becoming more usable, as long as you kind of have that cover that if still somebody needs 2D, that you can provide it. But there's some definite benefits. So you improve recognition of parts, being able to turn the model around to see what's behind there, what's inside there. Parts being assembled, disassembled, illustrated parts data, interaction with the 3D, like gltf, for instance, does support AR, augmented reality and virtual reality. So you could, in theory, use the files you create in here in those systems as well. We previously talked to a company called Vuzix who do glasses that you can actually wear to help you with field service and things like that. So there's a lot of possibilities now. We have the 3D file, what you can do with it and take it where you can take it. It might not necessarily be in a manual. It might be on a pair of glasses that you can see and interact with. Vuzix Edit 3D, it is available as an evaluation program. So please drop me an email if you want to participate, and we can quickly send you the download details and a license key to work with Vuzix Edit 3D. In summary, as we started off with data exchange, there's certainly lots of ways to get files out of CAD systems. We would say STEP is the most common, and you can usually easily get the information. We selected that format, gltf. If you're interested, Google it and you'll find out more about it. Say Google actually use it themselves and have some technology based on it, and Microsoft support it in all software as well. Archiving, we came up with the Vuzix Edit 3D native format, so you can save things in particular states and then go back to them and work with them again. And I think now we've pretty much fully formed our strategy for 3D, and we will be obviously working on adding functionality to what we have already. And certainly there'll be more developments coming soon with the 3D viewing side. So we're now open to some questions. I'm hoping Don might join us here as well. So he just start opening his mic. Hi, Don, are you back?
Yes, I'm here.
Hi. So we have a few questions. The first one is VRML2 another format for 3D? I've not heard of VRML2.
Yeah, that's VRML2 is really VRML1 was the first standard. VRML2 is sometimes when you see the extension WRL, that's really a VRML2 file. There's some slight differences. It was really the ISO standard version, and it's what most viewers support is VRML2.
Okay.
Although it's essentially it's very similar to VRML1. It just has a few more capabilities and has better interactivity than VRML1.
Okay. There's a connection between VRML and X3D though, isn't there, as well?
Yes, essentially, yeah, that's a good point. X3D is really is an XML codification of VRML. So the two relate very nicely. One, you can encode directly VRML as X3D.
Yeah.
And then and then supported in a X3D is easily displayable in a browser.
Yeah, so we do support, although we didn't choose it for our viewing technology X3D, we do support it as an export format. So it was just that we found it a lot slower, didn't we, Don, of displaying the model and so forth. So
yes, it's just there's a right,
and the file size is bigger.
Correct, right.
Yeah. So there was less opportunity, mainly because it's probably text-based. Am I right? I don't know if I'm right, that less opportunity to actually optimize it.
Yeah, it's definitely, well, of course, gltf can be text-based too, but it's got JSON encoding, which is a really fast, lightweight format compared to XML. XML can be very verbose with all the tagging and all that and properties. So,
okay. Another question. I think I did answer this, but perhaps Don, you might want to, because you obviously still have some communications with S1000D community that there's no standard file format for 3D. Not that we found.
No, there's nothing as far as it's very non-specific in that respect. There's a little bit there about what a 3D format should be able to do in terms of like a requirement, more of a requirements document for a 3D format, but nothing, it doesn't address style or anything like that, which would be real important. And especially annotation would be important to address in a S1000D, and none of that is in there.
Okay, there's quite a long question. I don't know if you want to look at that, Dan. I'm not sure we'll have time to cover it now, all of it, but it's really about PDF. Can you clarify the support for 3D PDFs? I think we don't support 3D PDF.
No,
3D PDF.
Yeah, we don't. No, we no support for 3D PDF.
So there is particular products that focus on that, but we decided it wasn't really something we wanted to focus on at this time. It doesn't mean to say we won't do it in the future if there's a demand, but at the moment we don't support it. But to the person, sorry, go on.
Yeah, it just doesn't have the performance that the beauty of gltf is it's based on the WebGL or the HTML standard, so it's extremely fast to parse and load into a browser and supported directly by the GPU. So gltf is really the most modern and the most appropriate standard, I think, for web publishing. Although 3D PDF is certainly popular, and we may have to include something for that.
Okay. There's a question of I don't know if it's a question or a statement, but there's something about SolidWorks and creating drawings, vector-based images, and they're not clean. All I would say is that if you want to test Visx Edit 3D with those files, say from a step file from SolidWorks, then we'd encourage you to do that, because we've really optimized our filter to create really good vectors from those files that would be easier to work with. So I think that's what it's more of a statement that.
Yeah, that's right. That's pretty specific to SolidWorks. But it's an interesting question. We'd love to work with you on that and do some testing and to see what how we perform on that.
Okay. So there's another question here around animation. So this is the $1 million one. It's something we've looked at and we're still thinking about. We don't support animation at the moment. the thing is with animation, there's so many pieces of software out there that you can get, say, a gltf file you can animate, say, even with free software. So the debate is, do we build it into our software, or do we say you're just as well to do that in something else, and still you would still work in our viewer, So that's the kind of thing we're thinking of at the moment. So we wanted to try and get the kind of the basics right, and then debate if there's an easy way to implement animation. So we haven't got it as a function yet. We haven't put everything into this first version, but certainly the viewer should support it, and we're testing that at the moment. But that's our kind of only trepidation about supporting animation, is there's so many pieces of software already doing it. So I don't know what you think on that, Don. Have you got any thoughts?
Yeah, it's an interesting thing. I mean, there's really two aspects. One is the authoring part of it, and that's usually done through a series of recorded views that an author does. He places his views and along a timeline, and then that gets recorded. Those views get recorded in a publishing format, and then the viewer then has to play them back. Now, gltf will support that nicely. So it's certainly possible that we'll have something in our authoring tool. But like I say, the viewer would be able to support that directly.
Yeah. It's just we'd have to, if we wanted to implement it, we'd just have to make it as easy and simple as possible. But it's something we've thought about. So I don't think it'll be in the. It would also be something we would put into obviously VisX Edit 3D. So, but it's certainly something we're thinking about. So I can't really say anything more than that at the moment. It's not. It won't be probably in the first version anyway. Okay. Yeah, I think we answered that question. Perhaps I should answer this question about, does the 3D viewer support other 3D formats, or did we? I think at the moment we only support gltf, but there is a possibility we could extend that in the future, Don, if needed.
Yeah, you could. I mean, of course, we'd never want to try to support step or IGES or something directly in a viewer, because it's not designed for publishing. It would take so long to parse it in a viewer. But there are some other open formats that we may add, like VRML or something in the viewer.
Yeah, I think the 3D viewer market is very, very crowded. You just have to go and look online to find that out. What we obviously want to do is create a viewer technology for technical publications. That is our aim. So there's no point in creating us creating a CAD viewer, for instance, that Don just mentioned, like something that somebody would use within a company just to say, I want to look at that piece of machinery or whatever, and it's a step. That's not where we're going, because there's already thousands of viewers, and when I say thousands, there are thousands that already do that. So yeah, our focus is on technical publications as usual, and that's what we want to remain with. So I think that's it for the questions. Thank you for really good questions. If we haven't quite answered them, I think we'll the person who asked the PDF one, we're already communicating with, so we'll definitely go talk to them on that personally. And as I said, the 3D viewer, the evaluation of the 3D viewer, initially we'll probably reach out to partners that we've been working with our technology for some time, and then we'll open that up. Once we're through that stage, we'll open it up to other vendors as well. So I don't think it's going to take too long, but certainly VisX Edit 3D is here now. You can use it for the 2D, and you can use it for the 3D. But the viewer was still a bit of time away, but not. We're pretty close. So we should be making an announcement soon on the full availability of the SDK. So thanks everybody for joining us today. Really appreciate you taking your time to see us and to see the presentation. We have recorded it, so if you want to pass this on, you'll get a link. Even though you've attended, you'll still get a link. You might want to pass that to a colleague, or if you think of any other questions following the presentation today, then please reach out. And if you want to join the evaluation program, Evaluate with X88 3D, we're pleased to help you with that. So thank you, everybody. Have a great day, and we'll hopefully speak to you again soon. Thank you.